daily streak problem in Leet Code platform, and the problem main concept is about finding the minimum number of operations, increment operations on subarrays to form a target array. Here it is tagged as hard problem. Let's delve into the problem. You are given an integer array target. You have an integer array initial of the same size as target with all elements initially zeros. In one operation, you can choose any subarray from initial and increment each value by 1. Return the minimum number of operations to form a target array from initial. The test cases are generated so that answer fits in a 32-bit integer. Now, simplifying the problem statement, they have given a target array and we are given an array named initial which is filled with zeros. The size of the initial array is same as the size of the target array. How many minimal increment operations does it require for initial array to become the target array? The brute force approach is first increment all the elements in initial array from 0 to 1. That would cost us one operation because every array is a subarray of itself, and from there on we verify for each and every corresponding element whether the corresponding elements in the corresponding indices are equal or not, but that would give us a huge time complexity. Hence we go for optimization. Now the main intuition behind the optimization, I need only minimal operations to transform initial array into target array. So why to waste time for processing each and every corresponding element? If we observe the array, there is a sequence. Like here the constraints are given only positive elements. The array contains only positive elements and the array is unsorted. Like the elements are placed in random order. Also, we must not sort the array. Here is the advantage. So let me go for a notepad interface. So to explain the problem statement, give me a minute. Now this is my target array and initial. This is my initial array. Now the basic operation is increment all the elements by 1. So the cost as of now is 1. Now in this iteration we have this array updated initial array after one incrementation. Now target array check for the corresponding indices. In index 0 I have the same elements. In index 1 I have to increment it by 1. In index 2 I have to increment it by 1 2 times. In in index 3, I have to increment it by 1. Intuition behind optimization, I just want to know the minimum number of operations. So what if there is a mathematical condition so that I can arrive at the correct minimum operations, correct count of minimal operations to get the target array, required target array. Before that, let me complete the initial dry run. Now in target array, from sub array index 1 to 3, you can see the change. When you have to still increment the initial array by unit 1. So increment the subarray from 1 to 3 by 1 unit. Now the updated cost is 2, and the updated initial is and the target is there's a difference in the index of 2. Now I have to increment just the element in second index in initial array. Now after an increment, now my count is 3. Sorry, the cost is 3. Minimal operations are 3. This is the dry run of a test case. If we observe the pattern in target array, there is an increase from element in 0 index to element in first index. Again, there is a drop when you iterate from index 1 to index 2. Sorry, there's a rise. Actually, it's a rise. There's a continuous rise when you iterate from index 0 to index 1, then again from index 1 to index 2. Now from index 2, when you iterate to index 3, there's a drop. Again, when you iterate from index 2, index 3 to index 4, there's a drop. If we observe the pattern of rise and drop in the target array, we have got two rises, 2 times the value of elements rise. Okay, let me copy paste the array again here. Now rise, the first rise, which is the first increment, is target of 0 to, okay, let me do it the mathematical way. Now target 1 minus target of 0 equal to 1, positive 1 to be precise. Now second rise. Okay, let's decide the rise or fall after we calculate the difference between the present element and previous element. Now target of 2 minus target of 1, it's again plus 1. Now target of 3 minus target of 2. Here there's a drop, as you can see, -1 to be precise, because the difference between 3 sorry 2 and 3 is -1 here. Here we don't take absolute values, we take the exact values, because we want the minimal operations. And again, target of 4 minus target of 3 equal to -1. So we have got 2 times rise and 2 times fall. Now the first element we have started with the first element 1, and number of increments or number of peaks equal to, which is 2, and that gives a sum of 3. This is the entire intuition. And the first element in an array is the minimal count. Now in this target array, the first element, the 0 index element, is 1. So there is no chance that the minimal count of operations would be 0. So the minimal count of operations would be at least 1, or to be precise, the starting element of the array. Now in algorithmic point of view, this is like count only the peaks. The peaks are calculated as difference between consecutive elements. And let's dry run this one with another test case. Now this is my target element. Till now we have done step-by-step dry run and step-by-step verification of the optimized method. Now for this one, so the count is initialized as target of 0. Count is nothing but you can take it as cost or minimum operations. And now we have to keep on calculating the differences between the consecutive elements, exact differences of consecutive elements. Let's do it. Now to iterate over this array, obviously we have to loop over it. We have to initialize a loop. I'm just giving a crucial code snippet type. I'm not revealing the entire code. And here the number of elements are 5 elements, so I'm going to fix it for 5. Now let's start calculating the minimal differences between the consecutive elements. And the differences here we get 2 types of differences. One is positive difference and another one is negative difference. We only consider the positive difference because the negative difference don't have to contribute anymore to the optimized approach. So if the difference is strictly positive, only we add the difference to the count. Now here there is a glitch, there is an error. The number of elements here are 5, but I have taken I plus 1 for every consecutive iteration. I'm taking I plus 1, the difference between difference between the element in index I plus 1 and the difference between the element in index I, but I may get index out of bounds. So when n is 5, I have to keep my I restricted up to n minus 4, which is n minus 1, which is 4. And after completing this loop, we would get our final result as final result. That's all about this problem. This problem is based on greedy approach. Why greedy approach? When we observe, I have considered the differences, the positive differences, the peaks, the lows only once. I did not revisit any of the element. I did not revisit the choices. So optimization by selecting the choices only once. Main factor in this problem is peaks between elements. Peak difference is nothing but calculating the difference between two adjacent elements. That's all. And this approach has covered the entire edge cases in spite of being tagged as a hard problem. So I just observed the pattern and came up with an intuition that why can't we have a mathematical intuition. So you can represent this logic as a mathematical intuition, like sigma of target of I minus 1